Chuck, I'm going to talk about space telescopes.
I will see you later.
Oh, sit your ass down.
Okay.
All right.
If you must.
Here's how it goes. So I think many people don't know that the telescope and the microscope were both discovered within 10 years of each other. So, arguably, the two most potent tools in the scientist's arsenal are those two instruments.
One going out and one going in.
The large and the small.
Right.
That's right. And before Galileo first looked up, it existed, but they didn't call it a telescope. You know what they call it? A spyglass.
Oh, okay, that makes sense.
Okay. Just a spyglass.
Yes. Clearly, Galileo was just the first guy to see an academic application for this.
Exactly.
That's all. He was like, why is everybody looking this way? Did you ever consider?
Yeah, exactly.
Right.
Exactly. So that telescope was of a refracting variety.
Okay.
So it has a lens at one end, and then at the other end you have like an eyepiece.
Right.
And the light comes through that piece of glass, and then it focuses down to a point that gets magnified by the eyepiece, and you see an image. And it's very cool.
That is cool.
Okay? So, but there was a problem with that kind of telescope, interestingly. Because if you made the shape of a lens with it's like this, right?
Right.
Right, okay?
Right.
A convex lens. It looks like
lens.
this. Well, that kind of resembles two prisms attached to each other at their base, but one upside down and one right side up.
Okay.
So think about it. When light comes through a prism, you've seen the cover of Pink Floyd's Dark Side of the Moon. The light comes through, and it spreads
separates
into its colors.
Right.
So if a convex lens is sort of like two prisms, that tells you what is happening through that convex lens. Because the light comes through, the bottom half of the lens is like an upside down prism. That'll spread light into its colors. The upper one will spread light into its colors. So the red, the green, the yellow, the blue, all focus at a different place.
Oh.
So you can see an image, but it's like a rainbow around the image.
Right.
It's called chromatic aberration. That's what it's called.
That sounds cool. I know it's not a good thing.
No, it's not a good thing. Not a good thing.
I mean, don't give bad things good names. Chromatic aberration.
Have you been chromatically aberrated?
Yes, right. I'll take some.
So it still worked as a telescope, but it was not ideal.
Mm-hmm.
And it would take another 100 years before my man.
Oh, don't say. Let me see.
Isaac.
Your buddy.
My man.
Isaac Newton.
Isaac, who'd you think my man was?
I don't know.
All right, thank you.
Yeah.
So Isaac Newton said, I can fix that. Let's not use a lens, let's use a mirror. So he takes a curved mirror, the light comes in, it comes to a focus just like it did through the lens, except all colors of light reflected exactly the same angle. Solved the chromatic aberration problem.
You know, the more you tell me about this Newton guy, the more I'm starting to think he was really smart.
Plus, he's not this Newton guy, he's Newton.
Yes, true. Yeah.
It's not like this guy Joey. No, he is Newton.
Right. This is true.
Okay?
Right.
And I call him Ike.
You call him Ike?
Isaac Newton, he's Ike to me, all right?
All right.
All right, I'm just saying. So he invents this new kind of telescope, a reflecting telescope.
Reflecting.
All telescopes today are
reflecting telescopes.
Yeah, and this man set that into motion.
This guy.
That's right. So now we got a good telescope in the house.
Okay.
All right. So now, what next? So you look up to the night sky, and it's beautiful. It's beautiful.
Yes.
It's beautiful.
It is.
Problem is, we're looking through an atmosphere.
Right.
So obviously, you don't want to look when there are clouds.
Right.
But even a clear sky, there's turbulence in the clear air.
Okay.
You know what it's like? Have you ever been on a hot day and you look on the surface of the pavement and you see the image kind of undulates? That's where you get mirage.
Yes.
Mirages from.
Looks like water.
Looks like water, right? Yeah. That movement of the air, preventing you from seeing a clear image, that's happening in every direction you look in the sky.
Wow.
Because different pockets of the atmosphere undulate at different temperatures.
Gotcha.
Okay? And so the light is coming through.
And it disturbs the light.
Different temperature areas, different densities. So if you go from one density to the other, you end up bending. And so the light does this, and then it gets to your telescope, and it keeps changing, and it blurs the image.
Wow.
So you can see big objects, not so bad, but really small objects that are next to each other, their two images can end up blurring into one blob.
So how do you get rid of that?
Get above the atmosphere.
Oh. Well, I bet you Isaac Newton didn't do that.
Except
Except
he drew the diagram that gave us our understanding of what orbits are.
Oh my, this guy. You can't get away from the genius of Isaac Newton. I don't care how you try.
I'm just saying. So here's what you do. You put a telescope into orbit.
Ah.
All right. Now you get all the benefits of a great reflecting telescope, but now you don't have the problem of the atmosphere interfering with the image.
So now here's my question.
What's that?
Is there any equivalence to atmospheric distortion in space? Is there
No.
none?
Okay. Because there's no atmosphere.
No, I'm saying the equivalent of
some other thing.
Some other thing that would be the equivalent of atmospheric distortion.
No.
Yeah.
Okay.
Okay. I'm cool with that.
The answer, no.
Okay.
Okay. So what we have is the urge to do what we were doing on the ground, but from space to get better images. All right. So it turns out the universe is talking to us not only with visible light, but with other forms of light.
Okay.
Light that you can't see.
Really?
So there's visible light coming to us.
Right.
And we thought that was everything because our eyes, why wouldn't your eyes see everything there is to see?
Why would my eyes lie to me?
Exactly.
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 This is what I'm saying. This is what it is.
Methods and tools of science have revealed it's not just visible light, red, orange, yellow, green, blue, violet of the rainbow. There is ultraviolet, X-rays, gamma rays, radio waves, infrared, microwave. We've heard of all of these.
Yeah.
Because we exploit them in everyday life. So all of these bands of light are talking to us through different kinds of objects in the universe. So if you want to talk to the universe, you want the universe to talk to you, you need a telescope that specializes in each of those bands of light.
So each one is like a dialect.
Yes.
Right.
I like that.
That's kind of cool.
A dialect of the language of the universe.
Right. Hello, governor.
All right. So it's clear that like the first of these telescopes you think about would be like a visible light telescope.
Makes
So
sense.
the first of the big telescopes in space was the famous Hubble Space Telescope.
Of course.
All right. You know how big that was?
No.
Size of a Greyhound bus.
For real?
Yes.
Wow.
Yes. And it was designed exactly to fit in the payload of the space shuttle.
Right.
Because then the space shuttle can take it up and it can service it and go back to it and fix it, any problems it had. And it did have some early problems that we went up and fixed with subsequent astronaut missions.
But it's speaking in visible light. Edwin Hubble.
So the Hubble telescope specialized in visible light and also ultraviolet.
Ultraviolet as well. Okay,
yes,
cool.
Okay? Because ultraviolet gets blocked by the atmosphere. That's what the ozone layer is for.
Exactly.
Okay? All right. So, got that one done. Okay? Well, now we got more bands calling to us.
Yes, we do.
Okay? So the Hubble telescope sees everything that you would see and then some with your eyes. How about the other bands of light? There's a telescope named after a guy named Lyman Spitzer, who was a professor of mine.
Oh,
actually.
really?
Yeah, at Princeton.
Cool.
Yeah. And they sent up that telescope that specializes in infrared.
Nice.
Okay? Then we wanted to open up the X-ray band of the sky.
Okay.
All right. So there's a telescope named after a famous astrophysicist named Subrahmanyan Chandrasekhar. Okay.
Okay.
And so we shortened all that to just Chandra.
Oh, thank God.
Okay. So there's Chandra X-ray Telescope, and that specializes in things in the universe that give us X-rays.
Just in X-rays.
Do you know what one of them is?
What?
Black holes.
Right on.
Not the X-rays don't come out of the black hole; they come out of the vicinity of the black hole.
Gotcha.
Okay, and so that is that found monster black holes in the universe. It's very cool.
Nice.
This is without X-rays, you would not even know to look for black holes. You couldn't even find the things. Okay, I'm not done yet.
Oh my goodness. All right. What else?
What else we have? So gamma rays don't make it down; they get blocked by atmospheric particles. So there's a Compton Gamma Ray Telescope up there. Arthur Compton was an American physicist.
Okay.
And so all these are named after physicists.
Does the Gamma Ray Telescope turn into the Hulk? Because that would be...
I'm not authorized to divulge that. That's a state secret from, what's the name of that organization in the movie?
SHIELD.
The SHIELD. It's a SHIELD secret.
Okay, cool.
So here we have, did I list all four? So we have the Hubble telescope, visible light, Spitzer telescope, infrared, Compton gamma rays, and the Chandra X-rays. So these are the great observatories that are orbiting the Earth.
Well, what's all the talk about Webb and the James Webb
telescope?
telescope?
I can get there. I'm talking about the current.
Oh, okay.
Slow down,
All right,
dude.
I'll slow down.
Okay, so now, Hubble, we milked that puppy.
Yeah.
It's been up since the early 90s.
Wow.
And so, yeah, we got 30 years of really good data off of that thing. In fact, the Hubble telescope may be the most successful scientific instrument there ever was.
Why so?
16,000 research papers came from it.
Nice.
From 4,000 research scientists.
Wow.
It's likely the most productive scientific instrument there ever was.
How do you?
And a multinational collaborations as well. So there's a committee of your peers called the Telescope Allocation Committee. Every big telescope has one of these.
Okay.
Okay, and there's several people on it, and they read your proposal and decide whether or not they will allocate the time you ask for.
Interesting.
These great observatories were huge windows opened to the dialects, to use your phrase, of the cosmos as they spoke to us. Notice there were no radio telescopes in that group.
Right.
Because radio waves come right through the atmosphere,
And we get them.
untouched, unimpeded. They're big enough so that the turbulence in the atmosphere. In fact, you can use a radio telescope with clouds.
Right.
Okay, in the daytime.
Right.
So not all bands of light are susceptible to what the atmosphere would do to us.
That's one of my favorite stories is about the cosmic background radiation.
Yes, in fact, that's microwaves.
Microwaves.
And so, because the Big Bang is talking to us in microwaves, and we have microwave telescopes on Earth's surface
Right.
That work great for that. So now, we're kind of done with the Hubble. It's still doing some work, but it's not like groundbreaking like when it was first launched.
Okay.
So we have the next generation of the Hubble Space Telescope.
Okay.
And it used to be called the NGST.
The next generation.
Space Telescope, okay? And then we find somebody to name it after, James Webb,
Right.
who's not a scientist. I think it's the first telescope was not named after a scientist.
Wow.
But he was head of NASA while we were going to the moon.
Wow. That's a pretty big deal.
Yeah, it's a big deal. So
Big deal.
the James Webb Space Telescope, scheduled to be launched in 2021. It's been delayed because it's unique design and engineering. You don't pull that stuff off the shelf.
No.
Okay? In fact, the telescope is so large, it doesn't fit in the fairing of the spaceship that's going to launch it.
Right.
So they had to take the mirror and fold it up like the petals of a flower. Okay? Then the thing gets launched, deployed, and then it unfurls.
Nice.
Into the mirror. It's a brilliant engineering concepts to make this thing happen.
But that sounds dangerous.
This is tuned to observe galaxies being born at the beginning of time.
Wow.
It is tuned precisely for that. And it can observe other things. All right? You can look deep inside. It's tuned for infrared to make that happen. And it's got a huge collecting area. So it can look deep inside of gas clouds because infrared can penetrate clouds. And by the way, that's not something unusual to people's awareness because
It's still hot on a cloudy day.
no,
No, I'm joking.
okay. When it's foggy out, you're not supposed to use your brights,
Right.
Because they're very blue. Blue scatters into clouds.
And then it looks like a movie
The
screen.
movie screen, right? So you use your regular lights, but if you had fog lights, it's like they're like amber.
And they're right.
Okay, and they'll punch right through the cloud. Deep red lights would punch through even better.
Oh.
Infrared, the cloud's not even there.
That's right.
It's transparent, the infrared. So you take an infrared pointed at clouds in the universe, you see deep down in, you can see the formation of brand new stars and planets.
Ooh.
Yeah. So here's just an interesting thought. Different materials are transparent to different bands of light.
Right.
All right? So there's a wall here. We're surrounded by 6 sides, floor, ceiling, and 4 walls. That's because visible light doesn't penetrate these walls.
Right.
Okay? But I can open my curtains, light goes straight through. There's a window there.
Right.
Window is transparent to visible light. Your cell phone works in here. Why? Because microwaves pass through the ceiling.
Right.
Different things are completely transparent to different bands of light.
It's you're right. It's like laser surgery. They use different
Oh, to get to different depths.
Different depths in your body.
Within the body. That's
Yeah.
correct. So it's just, when we think of something as opaque, it's only opaque for a particular band of light and not other bands of light.
See, that's the cool thing about science. Something is true, but then if you look a little deeper or a little farther, it's
conditionally true.
It's conditionally
Correct.
true.
Yeah. That's right. There are no absolute truths.
Right.
That's right. There's like, this is true for this, but not for
But
that.
not for
There's something else going on over here.
Yeah.
And here it's kind of like that, but a little different over here. Right. And there you have the entire electromagnetic spectrum serving the curiosity of cosmic scientists, which we call astrophysicists, as we decode the nature of the universe. Oh, I'm done here. Chuck, do your thing.
Good stuff. Good stuff. Of course, it's really expensive to get video of telescopes in space. You think it was easy to get this? Well, how about this? And the James Webb Space Telescope? It isn't even in space yet, but we can still show you this clip. How? Storyblocks. Storyblocks Video gives you studio quality 4K stock video without blowing your budget. We use it at Star Talk, and with their unlimited plan, we can find a video for just about anything. Here's a donkey. Head to storyblocks.com/StarTalk and sign up now. Audio, video, photos, templates, whatever you need, Storyblocks has it all. We even use some of their clips in this video. Check out the link in the description to learn more about Storyblocks Video.
What's a donkey doing? We're done here. As always, keep looking up.